Designing data integrity. In a previous nugget, we looked at how to create and alter constraints. Specifically, we looked at how to enforce domain, entity, and referential integrity. This nugget, we're going to go over some of that again, but we'll take it to the next level by actually utilizing some of these techniques to see how they work. We'll start with a whiteboard just to define data integrity. We'll talk about those levels of data integrity, domain, entity, and referential integrity, and we'll also compare constraints to triggers. Sometimes triggers are just more flexible and the right answer for doing things like referential integrity and enforcing business rules. So we'll look at when you should use one over the other, and we'll also go over a couple of design tips. From there, we'll jump into the virtual nugget lab, and we will design our data integrity strategy, first using constraints, and then we will see how to enforce both referential integrity and data integrity with some business rules using triggers. Let's start by talking a little bit about what data integrity is and how we can accomplish it in our databases. Data integrity is all about ensuring data quality. We should know, based on the requirements for our database and our applications, what we want this data to look like, so it's our job to enforce that, and data integrity using constraints is how we're going to accomplish it. And that could be anything from ensuring that a row meets our requirements to a column to multiple rows across tables. And that's why we have these various levels. That's why we have entity integrity to do things like enforce uniqueness or set a primary key to ensure identification. Domain integrity to enforce valid values, ranges of values, values that depend on other values within a table, and then referential integrity, which is records relying on one another across tables. So we have lots of constraints to help us out at all these levels. At the entity level, the row level, we have the primary key for identification purposes. We have unique indexes, which are useful for ensuring that a column or multiple columns contain a unique set of values. At the domain level, we have the foreign key constraint, which goes into referential integrity, but we put this at the domain level to reference a primary key in another table. Check constraints to ensure valid values or formats. Defaults, this is good because if someone doesn't supply a value, then we can put a default in there. That'll help with data quality. Nullability, good for mandatory fields. And then for your XML columns, we can use an XML schema to enforce the structure of an XML document or data. At the referential level, again, we have foreign keys that reference primary keys in other tables to enforce relationships. We can use check constraints, and then we can use triggers for those complex business rules, or just doing things that constraints can't do or aren't good at doing. Other ways to enforce data integrity would be stored procedures and, again, triggers. A great way to enforce your own custom logic and business rules. So when it comes time to actually design your data integrity strategy, what do you use? Constraints or triggers? And a lot of this time, this question will answer itself. But generally, if this question does come up, you should first always try to use constraints if you can, because they're declarative, they're built right in to the table, they're easier to find, easier to manage, and constraints are proactive. So data is not even touching the table if it doesn't pass the constraint. On the other hand, triggers are reactive, but they are excellent for that complex logic or tricky business scenarios that you just cannot do with constraints. One of the limitations on constraints is that they apply to the current table. Now, you can get around that with check constraints by tying them to a function, but again, that's kind of unorthodox, and triggers just feel more right in that scenario. So triggers can reference other tables, and we get access to the changed data via the inserted and updated table. So it's generally a lot easier to work with triggers than it is constraints when you're referencing other tables. Also, constraints return these cryptic SQL error messages. So a lot of the times you're going to get with your application developers so they can trap these errors and give something a little more meaningful to the user. So there'll be a little more work involved there. While with triggers, we can do custom error messages right inside of them, so we can bypass that whole level. And application developers can just bubble those error messages right up to the user. Just a couple of quick tips here. When working with constraints, don't forget that you can disable them, which is very helpful. You can get a performance boost, among other things. And always remember to use meaningful names when it comes to constraints. I don't know what it is about constraints, but if anybody's worked with multiple databases or other people's databases, that constraints node is always filled with system-generated names. Probably because people use the designer to do things like defaults and check constraints and all that, and even foreign keys and primary keys. And when you do that, SQL Server generates the name, and it's never descriptive, and it's always a mile long. So whenever you go into somebody's constraints folder and you see all of these constraints, none of them make sense. You have to go into each one to try to figure out what that constraint does. So a meaningful name can go a long way, especially when it comes to constraints. Let's jump into the Virtual Nugget Lab and see how to work with constraints and come up with a data integrity strategy. Welcome back to the Virtual Nugget Lab. Let's get right to it here and head into SQL Server Management Studio, where we have a new project, 17.design constraints. So we're going to start here by just designing constraints for a table that span all of the different levels, domain, entity, referential, and I'll show you how we can disable constraints at the single constraint level and then all the constraints on a table. So we're going to go into Nugget Demo DB. We have a table that we should be familiar with by now called Learner Nugget Activity. This is a table that in a recent Nugget we indexed the heck out of. Now we are going to add constraints. We have no constraints on this table. In fact, I even removed our clustered index and our primary key because we're going to add our own on here by adding a primary key. So let's start with the default here. We're going to add a default to this table on our activity ID. This is going to be useful for key generation. And we're going to make this a new sequential ID because we're also going to put a clustered index on this table when we create that primary key, which will ensure that our fragmentation is low. So pretty straightforward here. Alter table, table name, add constraint, name of your constraint, type of your constraint, and then your expression. So we're going to add a default. Here is the expression, new sequential ID, and we're adding this all to column activity ID. So let's switch our databases here to Nugget Demo DB, execute it, and now if we refresh our constraints folder, we should have our default there with a nice, easy to understand name. So there's our default tied to our column. You can also see this if you right click on a table, go into design, choose your column. Here is our default value right here. Excellent. So if we did it this way and came in and typed it and then save it, we would have some cryptic name here under constraints. So doing it through T-SQL is nice here because we gave it a nice friendly name. So since it's a default, now we do not need to supply that on insert statements. It'll get automatically generated. Now the next thing here, null. See anything in this table that could be nullable? Action position was a good one. And we already have it set up as a null value here, but just to show you, if you did want to add nullability to a column, you can alter a table, alter column, name of the column, and then just respecify its properties. So in this case, it's an integer data type. We'll make it nullable, and that would have made it null if it was not null. All right, now keep in mind, though, if you switch nullabilities, you may need to run an update statement previous just to make sure. If you're going from null to not null, for instance, then obviously you can't do that if there's a null in the column. But keep in mind, you can put a default and then run that, and it'll fill it in with the default value. Moving on to check constraints. Check constraints are great for enforcing everything from the format of data to the range of values in a column to specific values in a column to a column that relies on another column within a table. So here we are going to say our action column here should only contain a specific range of values. So we're going to alter the table, add a constraint, give it a name, and then we're going to say check, and then our expression is going to be action must be in these values. So pretty straightforward constraint there. Let's go ahead and add it. And now we should also see this in our constraints node. There it is. And now if we want to test a few of these, we can, for instance, run an insert statement that will contain an invalid check constraint. If we run this, we're going to get that cryptic error message that says, no, sorry, you violated a constraint. So yeah, it's not very descriptive. That's where the application developer can catch this error and then give a more friendly name. How about just displaying here nullable values? If we execute this, we're not supplying action position because we made it nullable, so it should nullify that field, and we'll look at the results here shortly. Finally, here we have a valid one containing all the values. So this one should fly, and now if we want to look at all of those, well, there should only be two since the first one was rejected, but here it is, and we have a nullable value here for action position. So enforcing data integrity at the column level is pretty straightforward. It's really just understanding, again, how you want the data molded when it comes into this table. So it's all about designing your constraints to ensure that happens. Oh, and also notice our sequential ID was generated. See that? Right in order, right here. A0, A1. So that's the next sequential unique identifier there. So just wanted to show you that one as well there, that our default is indeed working along with our check constraint, along with our nullability. Let's move on to entity level constraints and data integrity. We'll start here with a primary key. We need a primary key on our table. So what we're going to do is add a constraint, PK activity D, which is going to be marked as primary key and clustered. So this will add a clustered index that is also a primary key. So now we have unique identification, and now if we want to, we can also relate this table with foreign keys from other tables. Remember, in order to use foreign keys, you need to have either a unique index or a primary key constraint. So activity ID gives us that. What about a unique key? Now let's say, for instance, that we would never want a learner on a nugget to perform an action at the same time. So we couldn't have the same person bookmark the same nugget at the same exact time. Now, even though that scenario is very unlikely to happen, it's just something that we can prove here and show by using a unique key. So we're going to create a unique key, a unique index, I should say, right on learner ID, nugget ID, and action position. So in the super rare chance that it does happen now, it can no longer happen. So we're just going to add a constraint here, give it another useful name, unique, non-clustered across those three fields. And if we hit execute, that will do it. And now we can see our unique constraints down here in indexes. Another reason you want to properly name them so you can identify them visually. And now we can see we have regular indexes, we have a primary key clustered index, and then we have a unique non-clustered index. Moving on, let's configure referential integrity by setting up our foreign keys. And we have learner ID and nugget ID, which just simply means we cannot put a record in this table that doesn't have a valid learner ID or a valid nugget ID. So we're going to alter the table, add our constraint foreign key learner ID. That is the learner ID. So the foreign key in this table is learner key. We're going to reference the primary key in our learner table, which is going to be learner key. And remember here, you can set up your cascading options as well. We're going to say no action on both of these, which means we'll get an error if someone tries to delete a learner and that learner has activity, or if someone tries to delete a nugget and this learner activity table here has nugget data in it. All right, so let's make both of these. And now we should be able to see them as well here by going into keys, refreshing. They're already there, but there they are. And keep in mind, you can also see your unique keys in there. So this table is looking pretty good. We've got a lot of stuff going on. It looks like we got a pretty good design here. This table is locked down pretty tight. Now let's test it out. And we'll start here by testing our unique constraint. So this one should fly because we're putting in a record that doesn't exist across those three fields. Remember, we put a unique constraint here on learner ID, nugget ID, and the action time. So let's add that in there. Looks good. And now let's try to add that same record. We should get an error here saying that we're violating our unique constraint. Good. We can test out our foreign keys to make sure they work by changing the learner ID and then the nugget ID. So let's do learner ID first. We know that learner ID 50,000 does not exist. So if we execute this, we should get an error. Very good. And then we can flip that back and then change our nugget ID here. We know that that doesn't exist. So we can test out that constraint. Oh, I guess nugget ID 5,000 did exist. How about 50,000? Try that one. There we go. That's better. So this is why it's good to test out your keys, just to make sure you understand your data in your database. And finally here we can see one that's actually valid, even though the one we just did was valid, but this one will be valid too. And now we can see all of those by looking at learner ID 200. In fact, let's just take off the nugget ID here and look at 200. We should see our one with nugget ID 5,000 in there as well somewhere. And there it is. There's the one that was supposed to be invalid. That is valid. All right, so that's all working great. Now another thing here, disabling constraints. It's a great thing to do when you want to load up data. In fact, in our scenario, let's say that we have just a handful of data that we want to add in here for legacy reporting purposes. Say we had an action that we retired long ago, but again, we want it in here for reporting purposes. So this would be a good example of how we could disable constraints to get data in to work with other reports and then re-enable it. So we can enable a specific constraint just by doing a no-check constraint followed by the name. You can enable all constraints by using a no-check constraint, passing in all. And here's another good one. If anybody's had to do this before, I've done this a few times, where you need to disable all constraints in the database. You can use the undocumented stored procedure SP_for each. And then you can disable all the constraints because that stored procedure will loop through every single table. All right, so there's a couple of ways to disable constraints. So if we disable all constraints here, actually let's just disable our check constraint. Disable our check constraint. Now we can do our load here, and this should work as it does. And now we can re-enable all of our constraints. And now if we try to insert that value again, will violate that constraint because it is turned on again. Just remember to always test your constraints after you create them. Let's move on to triggers and see how we can enforce a little more complex business logic. I'll show you here how we can enforce data integrity using triggers and also how we can enforce referential integrity. So let's say that we have a business requirement, and that requirement is that non-subscribers cannot perform actions such as rate or bookmark against our videos. So what that means is, first off, we're going to need to track subscribers. So we're going to add an isSubscriber field inside of our learner table. I added that. I made it not null, and I added a default. So right now, everyone's a subscriber. We'll change that when we get into our tests. The next thing we're going to do then is create a trigger on our learner nugget activity table that is an after trigger that is going to check to see if the data coming in is from a learner that is not a subscriber and the action is rate or bookmark. So if those conditions are true and this inner select here returns data, then exists will be true. We're going to raise a nice friendly error that'll get sent back to the application tier, and then we will roll back the transaction, meaning this insert will have never happened. So by doing this, we're doing a couple of things, but you can see triggers are great for enforcing complex business logic and also returning friendly error messages back to the caller. So let's just do this. We need to highlight all the way up here. So we change our database to NuggetDemoDB, create that trigger, and now we can test it out. So the first thing we're going to do here is just update a learner. Learner number 999, we're going to set their status to 0 here so they are no longer a subscriber. And now if we try to insert a value for that learner and it's going to be rate, we should get an error. And there it is. There is our friendly error message and that the transaction was aborted within the trigger. So it never actually made it into the table. So that's a pretty good example on how to use triggers to enforce data integrity, especially ones that need to go outside of the current table. We get access to the inserted table, which we can then join to other tables as we did above. Let's try one more scenario. So this time what we're going to do is use 2 triggers to enforce kind of an interesting situation. So let's say that we want to allow internal staff to delete categories. Categories get old and they change over time. But because we're going to have so many courses tied to these categories, we're going to do something special here with the business rule. We're going to say that if we delete a category, then roll it up to its parent category. So we'll do the old switcheroo. Inside of our trigger, we will take that deleted category, find its parent category, and then update all of those categories in our course category table, because remember, we have a many-to-many relationship here between courses and categories. We'll update them with their parent category. We're going to have a second trigger in place that does not allow deletion of root categories. So anything with a null parent category ID is known as a root category. All the other ones have parent category IDs associated with them. So it's a complex business rule and one that we couldn't solve using constraints. So a trigger is a perfect solution for this kind of scenario. And just to scroll down a little bit here, let's take a look at our data. So here's an example. We're going to take this Microsoft messaging category, and I also added the parent category here in the query. And if we delete this, these courses should all get rolled up to the root category, which will be IT training. All right, so let's try this. First, we're going to create our first trigger here, which is going to be to parent category on delete. This is an after delete trigger. So when a category gets deleted, we're going to join the deleted table to our many-to-many, our intermediate course category table, and we'll update the category ID of any course with that category ID to the parent category ID of the category that was just deleted. So that's all this trigger is going to do. Let's create it. And then our second trigger here is going to be our trigger that rather than a delete, will roll it back if we delete anything that has a parent category ID of null. So we're just going to do a quick exists, run a query using against the deleted table that looks for those null parent category IDs. If it comes back and it exists, then we're just going to raise an error and then roll back the transaction. So this will only come back as an error for those 3 root categories that we saw. So let's go ahead and create this one. And now if we scroll down, we're going to disable constraints, all of them. Because if we look here on our category table, if we look at our keys here, we have a foreign key. So we couldn't just do this by itself because we're referencing a foreign key constraint. So we need to disable that. Now we can run it, our delete statement here. And you can see already that we have 5 rows affected. So those 5 courses got updated with the parent category ID of Microsoft messaging, the one we just deleted here. And our one row that affected was the delete statement. So that category should no longer exist. It's always a good idea to re-enable your constraints after you do things like this. There we go. And now if we run this query again, we should get nothing back because that category no longer exists. If we want to see those existing courses, we can change this to IT training. And we also need to change this to a left join here against our parent category ID, since this IT training has no parent category. So that would ruin our query if we left that as a regular join. And there it is. Check it out. So that worked good. And just another example of how we can use triggers to do more complex data integrity. In the CBT Nugget, we learned how to design for data integrity. We started off with a whiteboard just defining what data integrity is, defining the various levels, and going over what constraints are within those levels. We also talked about the differences between constraints and triggers. It really just comes down to use constraints if you can, triggers or other means if you can't. We then jumped into the virtual Nugget Lab where we employed a data integrity strategy against our Learner Nugget activity table and used and created constraints at all the different levels: domain, entity, and referential integrity. And at the end, we saw how we could use triggers to enforce more complex data integrity and business logic. I hope this has been informative for you, and I'd like to thank you for viewing.